Good evening, everybody. It's time for Advent of Code, Day 7. I think the problem just dropped like half an hour ago, so it's relatively fresh. Let's hope it doesn't take too long so we can all get to bed at a reasonable hour. Okie doke, Day 7, the treachery of the whales. What's wrong with whales? I think whales are treacherous. A giant whale has decided your submarine is its next meal. A sperm whale. They're talking about a sperm whale. And it's much faster than you are. There's nowhere to run. Suddenly, a swarm of crabs, each in its own tiny submarine, it's too deep for them otherwise, zooms in to rescue you. They seem to be preparing to blast a hole in the ocean floor. Sensors indicate a massive underground cave system just beyond where they're aiming. The crab submarines all need to be aligned before they'll have enough power to blast a large enough hole for your submarine to get through. However, it doesn't look like they'll be aligned before the whale catches you. Maybe you can help? There's one major catch. Crab submarines can only move horizontally. You quickly make a list of the horizontal position of each crab, your puzzle input. Crab submarines have limited fuel, so you need to find a way to make all of their horizontal positions match, while requiring them to spend as little fuel as possible. Oh, I realized I forgot to make my Reddit post. There we go. Now everybody knows that I'm online. Okay, where was I? Make a list of horizontal position of each crab, your puzzle input. Crab submarines have limited fuel, so you need to find a way to make all of their horizontal positions match while requiring them to spend as little fuel as possible. For example, consider the following horizontal positions. Got a list here. This means there's a crab with horizontal position 16, a crab with horizontal position 1, and so on. Each change of one step in horizontal position of a single crab costs 1 fuel. You could choose any horizontal position to align them all on, but the one that costs the least fuel is horizontal position 2. The example is move crab 16 to position 2, 14 fuel. Move crab 1 to position 2, 1 fuel. This costs a total of 37 fuel. This is the cheapest possible outcome. More expensive outcomes include aligning at position 1, 41 fuel, position 3, 39 fuel, or position 10, 71 fuel. Determine the horizontal position that crabs can align to using the least fuel possible. How much fuel must they spend to align to that position? And then we take a look at the input. Okay. So I already have a sneaking feeling about this one. And the reason is that I think there's probably a way that we can do this in like sort of naively and essentially with n squared complexity, which is to say we basically just take a look at each position that is possible. So I guess we basically just like find the minimum crab's position, or the crab with the minimum position and the crab with the maximum position, and essentially just iterate over all those positions. And then for each one of those positions, we calculate how far each crab is there, and then we just figure out what the minimum one is. And I'm just to take a look at the input again, I'm guessing that like it goes up to, looks like maybe it goes up to like 1200, which means that we'll do like, I don't know, like on the order of 1 million or so iterations to do it naively, which isn't that bad actually. So we could set up the naive one and then maybe try not to worry about it getting too complicated going forward. Although I have a feeling that this style of solution is not going to work for part 2. Let's just go ahead and get that in there just so we can get it under our belt. Let me grab our input and we'll go ahead and plug it in to our file here. And the input's just comma separated and it's just a bunch of numbers, right? Let positions equals, we grab our input. Got to reload the window just because it's not auto-completing. And we are going to wait for the language services to come online. Just a little slower than normal. It might be because I have a bunch of stuff open on my computer right now. I'll see if I can't close some of this stuff here. Well, it's not a big deal. Okay, now we should be ready to go. Yeah, so we'll go ahead and split the input along commas. And then we will map them. Bunch of strings. We want to parse the string. It's a pretty common pattern that we're doing here. And then we want to specify that it's going to be a vector of. I guess we could do usize. I'm just going to do integers for now. And we also want to know what the minimum and maximum position are. So let's go ahead and figure that out. I'm going to go ahead and just do a fold over this. And I'm going to give it as its tuple, I32 max, I32 min. And then for my function, I'm going to just get the accumulator, which is actually the current min, the current max, and the current position value. And what we're going to say is that it's going to be equivalent to the I32 minimum of position.minimum of the current minimum and position.maximum of the current max. And is it complaining here? References. I'm surprised I need to pass a reference to an I32, but so be it. And what is it having a problem with here? Found reference to I32. Oh god, that's ugly. Is there a way I can do like an early dereference here in Rust? I feel like there was such a thing. No, it's not going to play ball. Gosh, that is not very good looking. At any rate, what we're going to do is we're going to iterate from the minimum to the maximum inclusive. And then we're basically just going to calculate the cost of moving all of our crabs to those positions. We're going to just say that the best position is equal 0 for now. It's probably not going to be let best cost equal I32 max. And here's what we'll do is we'll say that the current cost for position I is going to be our positions dot iter dot, we're going to do another fold here, and the initial value is 0, and the cost to move a crab at position pos to position I is just the absolute value of pos minus I. It's going to be the accumulator plus that. And then if cost is less than best cost, then the best cost equals the cost, and the best position is equal to I. And I don't have to put parentheses in Rust. Expected I-32 found, let's see, best cost. Oh, this is I-32 capital. Yeah. And then, of course, these need to be mutable. Easy to forget those. Best pause. We never read the value. That's fine because we're just about to print them. And what exactly is it asking for, this problem? How much fuel did they spend? So what you just need is the cost. So really, we don't actually even need to accumulate the best position. It doesn't matter. And so what we can do is we can just say that best cost equals cost.minimum of best, or best cost.minimum of cost, right? All right, what if we just went ahead and ran this? Gives us this value. I'm gonna just plug it in. We'll see what happens. All right, well, this has been, actually, I think it's the first time in this year's Advent code that I've gotten it right on the first time. So let's see how part 2 goes. The crabs don't seem interested in your proposed solution. Perhaps you misunderstand crab engineering. As it turns out, crab submarine engines don't burn fuel at a constant rate. Instead, each change of one step in horizontal position costs one more unit of fuel than the last. The first step costs 1, the second step costs 2, the third step costs 3, and so on. As each crab moves, moving further becomes more expensive. This changes the best horizontal position to align them all on. In the example above, this becomes 5. Okay. So now, what we're saying here is that essentially the cost of moving a crab to a certain position is now equal to the, essentially, is it the Fibonacci number? Is it the nth Fibonacci number? Let's see, if you have to move one position cost you 1. Let me just write this down. So if you have to move one distance of 1, it costs you 1 fuel. If you have to go a distance of 2, it costs you 2 fuel. So that's a total of 3. Is that right? Second step costs 2. The third step costs 3, which is 6. The fourth step costs 4, which is 10. It's not quite Fibonacci. It's basically, what is the name of this sequence? Is it like a geometric sequence? There is some expression that we can come up with that will let us calculate this mathematically, right? We're basically saying the cost of the current position is P of n is equal to the cost of step n is equal to n plus c of n minus 1. Is that correct? Where n is the difference, right? Let me just plug this into some of the example values just to make sure I understand correctly. So moving from 1 to 5 is 10 fuel, which is 4 units, right? And 1 to 5 is 4 because 5 minus 1 is 4. So that would be 4 plus the cost of 3, which we said was 6. So far that's right. There's an example with 3 here that does 6. So it does look like my formulation is correct. So the question, though, is there a way that we can actually just come up with a mathematical expression that doesn't require us to actually calculate previous values? I'm not sure if there is. but I'm going to just think on it for a little while. Because the other option is that we can essentially set up a recur, because like Fibonacci doesn't. I don't think Fibonacci has. There's no way to calculate Fibonacci numbers just using an algebraic formula. You have to basically build up from the bottom. And this may be something similar. I wish my math was a little bit better that I could say or prove conclusively. But let me just sort of think about it a little bit and see if I can potentially come up with something that's just a convenient. It doesn't look like multiplication will do it. Actually, I think it's this formula, right? I seem to remember n times n plus 1 divided by 2. And let's go ahead and actually calculate that out. So I guess if it's 5, then this is 15, right? And so if we do 5 times 6 is 30 divided by 2 is 15, that seems to check out. Then 4 times 5 is 20 divided by 2 is 10. What do you call this sequence? Is it geometric sequence? This is actually a little bit more complicated. Is this also like a binomial? I'm just sort of kind of reaching back into the depths of my memory to see if there's any kind of name for this. It's not really important because I think we've kind of figured it out based on the derivation here. But it's just something that will bother me if I don't know the name of. But we can kind of figure that out later. All right, so what I'm going to do first is, since I got the part A correct, I'm just going to go ahead and commit that to Git. And then we'll go ahead and make a copy of part 1. Got to do a couple of tweaks to make that compile, namely just update the cargo.toml file and double check that it compiles. That's fantastic. It does. Going to reload the window to get Rust Analyzer working. It's always just a couple of keystrokes to get the next thing going. It's not as efficient as it could be, but whatever. Okie doke. So what we basically said is that this calculation here needs to change so that the cost for moving this distance is actually going to be, and the difference, which is this here, times the difference minus 1 divided by 2. So I think it probably is better if we just make this a little bit more complicated. Let diff equal pos minus I dot absolute value, right? And then we return, let's see as in the local cost, equal diff times diff minus 1 divided by 2, and then it's going to be accum plus c. That'll be the new cost. All right, so that is considerably more expensive. It's at 92 million something. And I plugged it in. It says that's not the right answer. Okay, that's fine. Okay, so usually when we're in this situation, we want to make sure that this works in the sample input. Let's go ahead and plug that in. So that costs 123. I think I undershot. This is actually 168 fuel. Okay, did I miscalculate something here? Let's use our handy new. Actually, I kind of want to print things out all in one line. I was going to use my handy new debug macro that I learned about the other day, but that's not exactly what I want. Oh, this is actually going to print out a ton of noise, which is not awesome. Because I don't want the debug output of our incorrect answers. Moving 16 to 5. That is 16 minus 5 is 11. 11 times 10 is 110. And then 110 divided by 5 is 55. So this actually seems to indicate that my math, my convenient little math problem is actually incorrect. Where did I go wrong? Moving 1 to 5 cost is a different distance of 4. 4 times 3 is 12. Okay, so you know what? I must have misread this at some point. Either that or I'm just off by 1. I think maybe that's what it is. I'm off by 1. It's actually plus 1 over here. And this is not really the difference anymore, so let's just call this n. Now it's 168. Okay, so I think I was just off by 1. Okay, well, I answered that, but I think I'm gonna go back and just figure out like why I was off by 1. Let me actually just go ahead and commit this to Git, just so it's timestamped. So what I was saying is that if you want to go a distance of 1, the cost is 1. If you want to go a distance of 2, the cost is 3. If you want to go a distance of 3, the cost is 6. If you want to go the distance of 4, the cost is 10. So 5 minus 1 is 4. Oh, I see what I did. This is not, it's actually n plus 1 here. I think that should basically fix it. I just literally mistyped it. $93,214,037. Is that what I submitted? I don't know. I went to that other window. I think that's what I submitted. Let me try reloading here. Yes. Okay, I just literally typed the wrong formula there. So I'm gonna go ahead and like make that edit in Git just to make sure that we have the correct answer there. There's just kind of a funny way to be off by 1 is just to like literally type the wrong thing. Well, I am. Oh, it's not letting me push. Did I not add my private key? That's weird. Maybe SSH crashed. That's funny. I will go ahead and worry about the GitHub stuff later. But I think it looks like we were able to get this one done in relatively short order, which is great because it's getting late in the evening and it'd be awesome to go to bed. So thanks everybody who was watching or watching on YouTube. Take care, and we'll see you for day 8.